Hello. Today we're going to be talking about events that are mutually exclusive and mutually inclusive. And a set of mutually exclusive events are events that cannot happen at the same time. So my example here is if you want to flip a coin once and getting both a heads and a tails. That's impossible. You're going to get one or the other. You can never get both. So the Venn diagram for this, we're going to have our two circles, one containing event A and one containing event B, and they're never going to occur together, so there's never going to be an overlap. So what we typically want to figure out is the union of these. And that symbol is just, it looks like a U. So our calculation is the probability of A union B, which is when A or B occur together. So this is the probability of A or B happening, is kind of what that looks like. Which means when we see the word or, we think of a plus sign. So it's the probability that A occurs plus the probability that B occurs. So if I'm using my flipping a coin example, the probability that I get heads is 1/2. The probability that I get tails is 1/2. And so the probability that I get heads or tails, or heads union tails, we're putting together the probabilities of both of them. It's 1/2 plus 1/2, or really it's 1, because that's my full set. That's everything that could possibly happen. So two events are mutually inclusive if the events can happen at the same time. And so my example here is if you draw one card from a standard deck of cards and you pick either an ace or a spade. So these events could happen at the same time because I could draw the ace of spades. So my Venn diagram here, I'm going to have my two events, A and B, and there is an overlap. And this right there is A intersect B, where they cross. So my calculation here is, well, I want to find the probability of event A or event B, and if they, again, that's probability of A or B occurring. And so in this one, I have to take the probability that A happens, and again, because it's or, I add on the probability that B happens. But we have to consider the overlap. So we have to subtract off the probability of A intersect B. We do not want to count any one event twice. So if I consider the probability of A and add in the probability of B, I'm adding in then the ones that occur in both A and B twice in there. So we need to take out that set of numbers to make it correct. So let's use my example from above. The probability that I draw an ace from a deck of cards is 4 out of the 52. The probability that I draw a spade, there are 13 of those out of 52. And the probability that I draw the ace of spades, well, there's 1 of those out of 52. So to find the probability that I draw an ace or a spade is going to be when I add in the amount of aces I can draw plus the amount of spades I can draw. And that includes the ace of spades twice. I have an ace of spades in that pile, and I have an ace of spades in that pile. So I need to take out one of those ace of spades so I don't consider it happening twice. So we end up with 4 plus 13 minus 1 on top, which gives me 16. Out of 52 on bottom, and I can divide out a 4 on both, so that leaves me with 4 out of 13. And we are done.